Hello. In this second video on data tables, I'm going to show you again how to create the data tables, both vertically and horizontally, and show you how you could use that to kind of understand the main drivers of what matters for the answer in your model. In this case, the answer we're interested in is down here in the left corner of how much we need to save for retirement. So I want to know, how does retirement savings change given all the other inputs? And which of those inputs are most important for how much I have to save for retirement? So you'll notice I've set up the bones for basically 6 different data tables here. I want to know how interest rate changes affect how much I need to save, the bonus timing, when I get that in the future, how many years I have to retirement, right? The longer you have to save, presumably the less you need to save, but we can confirm that. Also, how much does your initial deposit matter? How much does your retirement spending matter? And how much does that donation amount that you want to make? How do those all affect how much you need to save every year? So to answer all those questions, we're going to use data tables again. So again, to review, when we've set up our data table, if we're doing it vertically, we want to have our inputs in the left column, and at the top of the right column, we want the value that we're going to capture, the thing that basically Excel is copying and pasting as it's changing these input parameters. So in this case, what we want is our model answer, right? I've already linked that to our model. And so we select this entire area. Underneath data, we go to what if analysis, data table. And again, because the interest rates, 2, 3, 4, 5, and 6% are in the column, we're going to direct those to the column input cell. So these values in the column are going to go to the column input cell, which in this case is interest rate. We're going to say OK. Again, it hasn't calculated yet. I'm going to hit F9 so it calculates, and we get the same answers we saw in the last video. Everything seems to be working well. All right, now let's go to the next piece. Let's go to the bonus timing. Again, we select the same array, the same general structure of the data. It's a different set of cells. We're going to select data table. Again, our bonus timing is in a column, so we're going to do the column input cell. But now our input cell changes. We don't want this to go to the interest rate cell. Instead, we want it to go to our bonus timing input. So you have to be careful, like you're directing the things you want to change in the data table to the right part of your model that's going to dynamically change those variables. So we change bonus timing, we hit F9 to update, and we can see our update. Lastly, years to retirement. Again, I select that left column and the right column together, data table. Now the column input cell is going to go to my years to retirement or retirement years. We say OK. Again, it doesn't update necessarily right away, so we have to hit F9, and now we see the update. Sorry, I actually made a mistake there. Notice that I pointed to C11, which is the years in retirement, not the years until retirement. So let's go ahead and delete that. To delete your data table, you can just delete the values inside there. We can select our outside area again, go to our data table, and now the column input cell goes to our years to retirement. So again, try to be careful about which cells you're pointing to. It can really throw off your answers. So here we update our values, and now we can actually do a little bit of analysis. As before, we saw that interest rates really matter, right? A difference between $45,000 and $9,000. When your bonus happens, it doesn't matter that much, right? $20,000 versus $21,000, not a huge range. Generally, you want that bonus to occur sooner, right? We prefer to get cash sooner rather than later, so you have to save less if you get it sooner, whereas you have to save more if you get it later. But again, not a huge impact on how much we're having to save. Now, years to retirement, it also has a pretty big impact, right? If we only have 30 years to save, we have to save more per year, 35,000. If we have 50 years to save, well, now we need to save only 12,000 per year. We have a much longer horizon. We're going to save a lot more times, so we have to save less each time. We also get more benefit from compounding in that case. All right, so that was vertical data tables. Let's actually see how we structure it horizontally next. So I've set up my data table in a horizontal fashion where across the top now, I have the variables that I want to change, or my inputs that I want to change. And on the left-hand side, I have the output that I want from my model. Again, linked to my annual savings amount. So in this case, what I'm going to do is select the top row, and then the second row as well, again, going left to my answer. In what if analysis, I still pick data table. And now the difference is that my inputs are in the row, right? They're in a row across horizontally. And so now I want my row input cell to direct to where the initial deposit is. So to be cell C4. I say OK, update my model, and I can see how my amount of savings per year changes as we change that initial deposit amount. To run through that one more time on this next example, we're going to do retirement spending. How much are you spending every year in retirement? The more you spend, the more you're going to need to save. So let's just verify that with our data table. And again, because my inputs are in a row, we're going to direct our row input cell to our retirement spending. We say OK, and F9 to update. And now we can, again, do a little bit of analysis. I'll finish out this last one so you can see it again before we analyze everything. We go to our data table. Again, the row input cell is going to our required savings for our donation amount. So our donation amount is there. And now we can do a little bit of analysis. So we can see at the top, if we get no initial deposit, we need to save $21,000 a year. On the other hand, if you do get that inheritance, you either inherit $100,000, well, now you only have to save $16,000 a year. Or if you inherit $500,000, which remember is more than the present value of what we needed, now you can actually withdraw a little bit every year, right? Negative means we can actually withdraw that over time, and so it's negative $4,000 a year of savings. If we jump down to retirement spending, we see that at the $100,000 level, we need about $20,000 of savings per year. However, if we start thinking about the $500,000 level over here on the right, now we're saving $93,000 a year. Right? We got to save a lot if we're going to retire on $500,000 a year. But we can see that that matters a lot, is how our standard of living in retirement clearly affects how much we need to save. And finally, the donation amount. This tells you how much that donation matters, right? To make that $1 million donation, we have to save $20,000 a year. If you make no donation, now you only have to save $17,000 a year. So you can almost think of, $1 million donation in 70 years is the equivalent of making a $3,000 donation about for every year for 40 years, right? Because that's the amount that our savings can reduce if we're not going to make that big donation in the future.